All right, today we're looking at the inside of the atom. Our goal is to identify the parts of the atom and their location. Now, the parts of the atom include the proton, the neutron, which are both found inside the nucleus, and it also includes the electron, which is found inside the electron cloud. The vocab words are basically the exact same as before, okay? They're the same as yesterday because it's the discoveries that the scientists made in our atomic model timeline. You do need to know these parts. However, they are not going to be on your quiz tomorrow on Friday, okay? They will be on next week's quiz. First, we're going to start with the inside, and we're going to start with the main parts, the nucleus and the electron cloud. What you have here, oops. Oh, it didn't work. Okay, you have the nucleus, which is made up of protons, which are positive, and neutrons, which are neutral. Okay? Neutrons do not have a charge. They are just there. They have mass, they take up space, but they do not have a positive or negative charge, and they are not going to affect how an atom reacts to a positively charged object or a negatively charged object. Okay? The nucleus is found at the center of the atom, and it makes the mass of the atom. Okay? Protons and neutrons are heavy in comparison to the electrons. Compared to you or me, they're really light, but for an atom, all of the mass is found in the nucleus, which is made up of protons, here in the red with positive, and neutrons in the blue. The electron cloud, on the other hand, is quite large compared to the nucleus. It takes up a lot more space, but there is virtually, basically, no mass. The electrons are extremely tiny. And electrons are negatively charged. Okay? The electrons are going around and around outside of the nucleus in the electron cloud. Electrons are basically the only things that can be changed from one atom to another. If you change the number of protons, you change the atom or the element that it is, and we're going to get to that soon. If you change the neutrons, then you end up with an isotope. So we'll look at those all three. Once again, electrons, extremely tiny, have a negative charge. They circulate around in the electron cloud, and they basically have no mass. Whereas the neutrons have no charge, protons have a positive charge, okay? And they circulate around, or they don't circulate, they stay in the nucleus in the center of the atom. The next point is that atoms overall, so atoms of any element, for example, one atom of oxygen, does not have a charge. This means that the positive protons has to equal the negative electrons. Okay? So to be neutral, you need to have the same number of positives and negatives. For example, if I have 6 protons, to have a neutral atom, I need to also have 6 electrons. Okay? Atoms in nature exist this way. They exist in a neutral form. Okay? The next part that we're going to look at is how you can find the number of protons. So the number of protons, what we do is we actually use the atomic mass. Now, where can we find the atomic, actually, no, sorry, not the atomic mass, the atomic number, I'm sorry. Where can we find the atomic number? Hopefully you guessed it. It is the periodic table of elements. So we are getting started to looking at the periodic table. What I need you to do right now, I need you to pause the video, go get a periodic table if you do not have one already. You also have, so Ms. Suarez has some copies, and you also have them in the back of your textbook. Okay, grab the periodic table, and we're going to have a look. Now, this next part here, it's a little bit difficult to put, but let's put the hydrogen atom. So the hydrogen atom on the periodic table is going to show up with a symbol of H. Okay? At the top, you have, actually on yours, it's at the bottom. You're going to have the name as well, which is hydrogen. Okay? Every periodic table is going to be the same. You're going to see the symbol. You're going to see the name, and then you're going to see a couple of numbers. These numbers, there's two of them. These numbers are important. They're going to help us for a lot of things. The first one, often found on the top, although on your periodic table it's actually found at the bottom. So we'll do it on the bottom for you for the same thing. The atomic number of hydrogen is 1. And we'll make it a little bit bigger and white. Okay, this number here tells you how many protons there are. So the atomic number now with this, it also gives you a little bit of other information. So before we said that atoms are neutral in their regular state. So if we go back quickly the slide before, we said that all atoms are neutral, which means that the number of positive protons they have equals the number of negative electrons they have. So if we know the atomic number, and we know that the atomic number of hydrogen is 1, this means that there is 1 proton. How many electrons would it have? Hopefully you said 1, and then you're correct. Okay, the number of protons in an atom needs to equal the number of electrons. The last number you're going to see is going to be on your periodic table up at the top. Okay, and that is going to be the mass number. Sometimes it's in a long decimal format. Sometimes it's a little bit shorter. We are going to round them up to the nearest whole numbers when you need to. So in this case, it would be 1. The atomic mass number, we're not going to cover in this lesson today, but it's going to be important later on. So it's also known as the atomic mass unit. The atomic mass unit tells us the mass of the nucleus. And what does the nucleus have? The nucleus is made up of protons and neutrons. Okay, so the atomic mass number is the total number of protons and neutrons. Once again, we are not going to look at this number today. We are simply going to focus on how many protons there are and electrons. Okay, so with your periodic table, you're going to have hydrogen, symbol, name, atomic number, atomic mass number. What I'd like you to do is I'd like you now to go and go and visit these sites. If you want to review what an atom is, there's an excellent video from Monkey See, which is on what an atom is. If you're interested in extending it further to looking at how we actually have been able to look at atoms, watch this one here with how we see atoms. Right now, though, you need to go to this PhET simulation to build an atom online. I'm going to make a second video for it, though, because I can't put the whole page on here, and I can't move the screen. So let me just stop the video.